Have you ever wondered how your body moves? How your muscles contract to lift an arm? How your legs propel you forward? Or even how your heart beats tirelessly in your chest? Today, we take these questions to the realm of biology and physiology. But what if I told you that the man who first looked at the human body and saw a magnificent machine, a complex system of levers, pulleys, and forces lived over 300 years ago? Meet Giovanni Alfonso Borelli, a true genius of the Baroque era and the man we call the father of biomechanics. He was a scientist who dared to apply the cold, hard laws of physics to the warm, living world of biology. And in doing so, he changed our understanding of life itself forever. So, get ready to travel back to the scientific revolution as we explore the life and legacy of the man who put the mechanics in biomechanics. Giovanni Alfonso Borelli was born in Naples in 1608, a time of immense intellectual ferment in Europe. He was a true polymath, a figure who seemed to step right out of the Renaissance into the heart of the scientific revolution. His primary career was as a professor of mathematics, holding prestigious chairs at universities in Messina and Pisa. But to label him just a mathematician would be a gross understatement. Borelli's mind was a whirlwind of curiosity, constantly seeking to understand the world around him through the language of numbers and logic. He was a central figure in the burgeoning scientific community of his time, an active member of the Accademia del Cimento in Florence, one of the earliest scientific societies dedicated to experimental investigation. Here, he rubbed shoulders with the intellectual giants of his day, including the famous anatomist Marcello Malpighi. This collaboration was crucial. While Malpighi was meticulously dissecting and observing the structure of living things with his microscope, Borelli was asking a different question. How does it all work? He saw the muscles, bones, and organs that Malpighi described, and his mathematical brain immediately began to see them as components of an intricate machine, governed by the same principles that moved the planets and made buildings stand. This unique perspective set him on a path to create his most enduring masterpiece. That masterpiece was a 2-volume work titled Asterisk and Motu Animalium Asterisk, which translates to On the Movement of Animals. Published posthumously in 1680, this book was the culmination of his life's work and a truly revolutionary text. For the first time, someone systematically applied the principles of mechanics, a field pioneered by Galileo, to analyze animal and human motion. Borelli's approach was breathtakingly original. He treated the body as a mechanical system. Bones were levers. Joints were fulcrums. Muscles were the sources of force, contracting to pull on these levers and create movement. He meticulously drew diagrams, breaking down complex actions into simple physics problems. Imagine him analyzing a person walking. He would calculate the center of gravity, the forces exerted by the leg muscles to swing the limb forward, and the counterbalancing motion of the arms. He didn't just describe running. He analyzed it as a series of controlled falls and propulsions. He studied jumping, calculating the explosive force required for liftoff. He even turned his mechanical gaze inward. The beating of the heart, he proposed, was not some mystical vital force, but the powerful contraction of a muscle pumping fluid through a system of tubes. He saw the lungs as bellows and digestion as a process of mechanical grinding. Everything, from the flight of a bird to the swimming of a fish, could be understood through the lens of physics. Borelli's investigations were remarkably detailed and quantitative. He wasn't content with just saying a muscle acts like a rope pulling on a lever. He wanted to know how much asterisk force it was generating. He performed some of the first ever calculations of muscular force. For example, he analyzed the bicep muscle flexing the elbow, and by measuring the distances from the joint to the muscle attachment. And to the hand, he calculated that the muscle must exert a force many times greater than the weight being held. This insight that our muscles regularly generate enormous internal forces was groundbreaking. His study of bird flight was another highlight. He dissected birds to understand their powerful pectoral muscles and analyzed the mechanics of their wing strokes, correctly identifying how they generated both lift and thrust. He even tried to design a human-powered flying machine based on these principles. While his design, like Leonardo da Vinci's before him, was ultimately impractical, the analytical approach he took was centuries ahead of its time. He also delved into the mechanics of internal organs. He studied respiration, describing the action of the diaphragm and intercostal muscles. He investigated digestion, arguing that food was broken down not by heat, as was commonly believed, but by the mechanical grinding action of the stomach walls, aided by corrosive liquids, a remarkable premonition of the role of stomach acid. While biomechanics became his most famous contribution, Borelli's intellectual appetite was vast. He was a product of his era, a time when the boundaries between scientific disciplines were fluid. His mathematical expertise naturally led him to astronomy, the most prestigious science of the day. Following in the footsteps of his hero, Galileo, Borelli made significant contributions to our understanding of the solar system. He conducted detailed studies of the moons of Jupiter, using their orbits to calculate the planet's mass. He also tackled one of the biggest questions of the 17th century. What keeps the planets in their orbits? Before Newton's universal law of gravitation was formulated, Borelli proposed his own theory. He theorized that planets were held in their elliptical paths by a balance between two forces: an outward, centrifugal force pushing them away from the sun, and an inward pull, a kind of solar gravity, pulling them closer. While he didn't get the details exactly right, his conceptual framework of balanced forces was a critical step toward Newton's later synthesis. He also worked in physics, investigating the principles of percussion and impact. In every field he touched, Borelli brought the same rigorous mathematical and mechanistic approach. He believed that the universe, from the grandest celestial bodies to the smallest muscle fiber, operated according to a single set of understandable physical laws. So, what is the legacy of Giovanni Alfonso Borelli? He was a pivotal figure in the scientific revolution, a bridge between the anatomical discoveries of the Renaissance and the physical laws of the Enlightenment. His school of thought, known as iatromechanics, from the Greek iatros for physician, viewed the body as a machine and sought to explain health and disease in mechanical terms. While this view was later seen as overly simplistic, it was a necessary and powerful corrective to centuries of speculation based on mystical humors and vital spirits. It dragged biology into the world of quantitative science. Borelli's greatest legacy, of course, is the modern field of biomechanics. Every time an athlete's performance is analyzed to optimize their technique, every time a prosthetic limb is designed to mimic natural movement, and every time a surgeon plans a procedure based on the forces acting on a joint, they are standing on the shoulders of Giovanni Borelli. He was the first to truly see the elegant physics in our physiology, the beautiful mechanics in our motion. He showed us that to understand life, we must also understand the laws that govern the entire universe. He taught us that we are, in the most profound and wonderful sense, machines built for living. Thank you so much for joining me on this journey back in time to meet this incredible scientist.